Hello, everyone. Azure DevOps Security Lessons Learned is the session we are going to look at today. My name is Björn Sundling. You can find me on various social medias and stuff like that on Bjompen. If you find Bjompen somewhere, probably me. I have a bunch of cool titles, but most of all, I spend my days doing DevOps and Azure stuff as a consultant in Advania. But for this session, most importantly, I am absolutely not a security person. In fact, I barely know what I'm doing at all. But I kind of stumbled into an issue a long time ago, which is interesting. So we have developers. I'm going to imagine most of you here are some kind of developer, right? You write code, you do awesome stuff, fantastic product, toss it into a pipeline, everything is awesome, yay. On the other side, we have our ops, cloud, whatever, peeps, doing their stuff, writing infrastructure as code or deploying landing zones, tossing it into a pipeline, and profit, off we go, fantastic. But there is a problem here, and that is sort of the in-between, because we tend to forget that one of the most sensitive places that we work in is between these two. If you are lucky, you are working in a full-on DevOps environment where everyone cooperates, but I'm going to bet you still forget about the products we're going to look at today. Now, we're going to start from or pass through this security matrix. This is from that company, Mitre Attack, I think it's pronounced. I don't really know. If someone knows, please tell me. This is a bit old, it's from 2023, but it is really useful because this is how we sort of traverse a system. And we're going to do that today. We're going to look at every piece of this matrix, no, not every piece, but every row of this matrix and see sort of what can happen. And we're going to start, of course, with the initial access to your system. Now, I'm not going to do boring demos or boring PowerPoints. We're going to look at this live, so pray to every demo god that the internet works. So in Azure DevOps, you have a setting called Allow Public Projects. Now, depending on when you set up an Azure DevOps organization, this is different. You may have it on if it's really old. You may have it off if it's not that old. And if it's created since August, you don't have it at all. In the GUI, it's still available through APIs because the GUI lies like hell in Azure DevOps. Now, this, of course, well, what it does, it allows us to create public projects. I don't know, it's not visible, but this is a private session. I'm not logged in, just accessing stuff from the internet as anyone. And I can access, well, just about everything. Now, if you have this flag enabled, anyone in your organization that has the correct access can set this up and sort of leak whatever data they want to. And that is all fine and dandy, because it actually does exactly what it's supposed to do. But it also does some more. So, I'm a PowerShell nerd. This is PowerShell. You don't really have to understand what's going on. That's not the important part. The command isn't important. What's important is this. Okay, what's important is this. Thank you. I'm having a bit of jerky internet. What I just did was call the base API of my organization, and what it returns is every single endpoint I have in my organization. This is every single API that my organization supports. Now, this is not per se a security issue, but you can actually tell a bit about it. You can sort of get new endpoints from plugins, from extensions and stuff like that. So what we can do is disable it. And we're going to look. Oh. Let's see if we can find one. I can see mine. There we go. If we disable it, instead, this is what we get. Now, this tells us two things. First of all, this flag, the Allow Public Projects one, it doesn't just allow me to do public projects, it actually enables public access to every single API in my organization. Cool, right? If we do something like this, disable it, then I can't see it. Instead, I get this answer. This answer also tells me that I have an anonymous user called in my organization. I haven't created that one. I don't know about you, but I don't like surprises like this. I like to know which users exist. Another cool thing, and this they actually changed in August, is that if I disable this setting, well, it doesn't really exist anymore. The GUI removes it. And the same goes if you create a new one. That's really good, but again, the GUI lies. You can still enable it if you want to. You shouldn't. In fact, do go in and disable this one if you have an Azure DevOps organization. Verify yourself. Because this is a good way to fingerprint, and even if I can't hack anything through it, it can help me do stuff like, I suddenly know what you have. What's your organization name? Do you have public projects? I can just call a user and say, hey, lost my access. Please fix this. And off we go. So we can see sort of a lot of good things using the public repositories from an organization. Once we're in, well, we need access stuff. We need to figure out how to destroy stuff, right? And we're going to start in here. This is very, oh, by the way, I hope is it big enough? Do I need to zoom in? Good. This is standard for PowerShell code. I have a module, I have 2 pipelines. I have a verification pipeline that triggers every time someone does a pull request. And I have a build pipeline down here that builds my module and does all the magic. So let's go in and look at this one. Anyone see the issue? You can actually go down here and look at the actual pipeline instead. And let's go in here. This is the built-in editor. There we go. No, doesn't twiggle anything. Everything looks good. But the problem we have is this. This task is run on version 2. This task is deprecated since way back. They are up to version 6 now. Now, I'm not saying there's an issue with this task. I don't know if there's an issue with this task. But according to some research done by another guy a year or so ago, about 40% of all tasks in Azure DevOps contains security holes or bad dependencies, stuff that leaks. There's a high number of them that's critical, which means basically if you run this in your environment, you are running code that allows for remote code execution. And it doesn't really say anything. It just says, everything is good. So I want to highlight the importance of doing security verifications and updating your YAML, your pipelines as well. This is one of the things that people tend to forget. I have a working pipeline. Yes, awesome. But when was the last time you checked that it's actually updated? We tend to update our code and make sure that we have no bad dependencies. We tend to update our infrastructure and make sure that it works. But we forget what's in between. On topic, in Azure DevOps, there's a couple of settings we can actually look at as well. For example, this one. So Azure DevOps tasks can run on PowerShell or Node, and Node versions that we can use is Node version 6, 10, 12, and 16, and 20, if I'm not remembering it wrong. Now, I don't write Node code. I don't know much about the Node environments. But I do know that Node 6 is not supported since, well, a long time ago. But I still have it enabled, which means, well, technically you could run Node 6 code on my runners. And the tasks built using Node 6, well, apparently they haven't updated those since Node 6. So, yeah. Another recommendation, make sure to actually follow up on new settings. Go in and disable stuff, like yay. Now suddenly I can't run node 6. I'm still insecure because we can run node 10, 12, 16, and so on, but it's better. Disable stuff you don't need. It really is that simple. Another feature of Azure DevOps, since Microsoft nowadays is always saying use Azure pipelines with GitHub repos, they added this one and not always enabled this one. If you are using GitHub repos with Azure DevOps pipelines, do make sure both of these are checked, because otherwise I'm running code on your public repos in your internal systems. It really is that simple. Make sure these are on. And they at least have added this stuff, which also, in our extensions list, is a good new feature. They added sort of warnings, deprecated, unused extensions. They made it easier for us to actually keep this stuff clean. Okay. So we now know that we have dependencies. We are running bad dependencies in our pipeline. Our templates, well, we need to keep them updated to make sure that we don't run old stuff. This is all good and fine and dandy, right? No? Perfect. Thank you. Let's go into the really fun stuff. How many of you are using Azure DevOps pipelines? A good deal of you. Have you set up your security properly? Access to stuff? Okay, we're going to look at some code. Again, quite standard setup. We have our pipelines, we have our build pipeline, we have our verification pipelines, and whenever someone does a pull request, I will run my verification pipeline, make sure that all tests run and all green, right? Quite standard setup. Let's go in and look how this looks. So in here, we have our policies, and we have our branch policies, and say build validation, validate code by building and rerunning and so on and so forth. And then we will run this pipeline. Let's read it again. Validate code by pre-merging and building request changes. Makes sense, right? This is what we want. So let's go into our pipeline. Oh wait, first we're going to look at this. Whoop. So if I do a pull request, it will run my pipeline, right? Exactly like it should be. Now who can do a pull request? Whoop. Let's see where we are. There we go. Readers can do pull requests. So anyone with read access to this repo or to this project can do a pull request to my repo. Now, consider what it said, pre-merging. Let's do this. We're going to create a fork. Now, of course, I already have write access here, but for the sake of it, we're going to fork my repo. And this is where we start to pray to the demo gods, because now it can actually go really slow. Now, up here we can see I have forked my repo. I'm in a new organization called Øredev 2 instead of Øredev 1. Let's do some changes into our verification pipeline. Now this one runs our tests. Pester, test framework for PowerShell. Let's change this one. Make a commit, and straight to main. Yep, we do it like this. And hopefully we can create a pull request to our source repo. There we go. I updated my module with some cool new stuff. Of course, I'm not going to tell you exactly what I've done, but let's create a pull request. Hopefully, it will trigger my build verification. It will run my tests, right? Because that's what I told it to do. So let's go in here. And again, pray to the demo gods. Okay. Oh, because I forgot to tag it. The important part is I changed the YAML of your verification pipeline, did a pull request, and run code in your repo. Now imagine if your tests instead checked in code or did like, oh, I'm going to test run stuff in my Azure environment or in my on-prem environment, on my self-hosted stuff. Then I'm running code on your self-hosted things. I have read access to your repo. Because read access means I can create pull request, and pull request merges the code, including, in Azure DevOps case, the YAML templates that you are running. This is an interesting security issue. Fortunately, we can actually fix it as well. So if we, instead of have everything in the same repo, we can do stuff like split it up like this. So we still have our modules, our code looks the same. And we separate our pipeline files, our YAML files, YAML templates into a different repo. Now we have to do some minor changes to it. For example, well, we have to define that we are actually checking out more than one repository. And we have to say that because inferring checking out code doesn't work the way it's expected, so we have to actually tell Azure DevOps to check out our code. But now, if we separate it like this, then if you do a pull request, you can't change my YAML templates because that's a different repo. Technically, you can do a fork of this one, do the same pull request, and it will change the YAML, but it will not run anything because this pipeline doesn't trigger anything inside this repo. It only triggers when we run code in here. So now, can't change our YAML templates. Awesome. Perfect. So we can do stuff like this, invoke code inside our YAML templates to execute whatever we want inside your build hosts. And again, if you're using build hosts, and we will get back to this in a short while. If you're using self-hosted build hosts, for example, then I'm running code in your environment. Awesome. We're going to step into the next one, and the green blob here is sort of in between because I don't really know where to put it. It's sort of in between somewhere. And it's actually exploiting kind of the same issue. So we can't change our YAML, right? But I still want to give you the possibility to change code, to write code. That's why we have repos. We want to share them and we want to do stuff now. When you do so, I'm an avid lover of tests. So if you write code, I hope you include tests to test whatever you do. And, well, again, PowerShell. So we're going to add some tests in here. There we go. Now we already know that I can, as reader, I can fork this, create my own repo, do my own changes, and create a pull request. I'm not going to go through that part again because the process is still the same. But let's commit, and let's do a my branch like this. And we can actually create a pull request right away, just because it makes it easier. So we create a pull request like this. And because we set up different repos, we can still have the same. You can't poison my YAML. It's going to run my verification pipeline. And hopefully, it's going to run green this time. Because what I actually did, well, I added a test. It runs my tests, runs tester just the way it should. And it runs an actual test of my code. So nothing weird, right? But let's go back and check what I actually did. Sorry? Absolutely. Whoop. There we go. So the test will shine green because it actually works. But I also added a little magic to include pipelines or include stuff into our build script. So let's go to our pull request. Test run green. Everything is fantastic. We approve it. We complete it. There we go. and hopefully in not a too distant future, it will trigger my build pipeline, just the way it should, right? But my test, instead of actually trying to rewrite the commit, I'm going to rewrite the build script. So I just rewrote the build script that I'm using instead in a test, because the test is run when you run builds, and that one just changes the file over there, and that file comes next. It really is that simple. And again, I can do this with read access. As long as you do not check detailed, but you do code reviews, right, on pull requests. You do detailed code reviews of every single line and verify that every single part of your code does exactly what it says to do. Yeah, no, not me neither. I'm just gonna, yeah, it looks good, merge. So simple miss like this, again, I'm in your pipeline. Thank you. But again, we can actually fix stuff like this. And it's not even hard. So let's go back and look into our next level pipeline. And we have our verification pipeline, we have our build pipeline. Now the problem with this is I don't want to separate the tests out of my code, right? Because it's the same repo, they belong together. I don't want to say, hey, you need to check out these 10 repos to do changes and keep track of everything. So I have to have them in the same repo. But what we can do is stuff like this. Most builders, most pipeline runners support the usage of containers. It's very, very standard. Instead of running directly on my host, I say run everything in this container. Most of them also supports read-only. So we can say, hey, in the work folder, we'll mount this as read-only and make sure that you can't do any changes in the work folder while do this. Again, we do need to change some magic. So instead of just running my build script, I now have to say, you know what, this part, because it creates an artifact that we need to be able to store, run this one directly on my host. You can separate this into multiple agents or containers as well. And say, hey, run everything in this container, but then take a new container and run the build script in, just to make sure, keeps things separated. And now, let's just go into a ready run pipeline of this. Because I promise you this is what will happen. When we run our pester tests, our test framework inside our container, the test framework that writes stuff into the build script, well, it's just going to say, hey, this is a read-only folder, can't write to the build script now, don't write to the build script now. And we have a red test, hopefully you have stop on failed, and so on and so forth. So, using containers, we can help prevent stuff like this. And now, it may not matter in this case, but again, start to think about it in the bigger scenario. If you're doing Impress code, like the landing zones thing, and this pipeline has access to the top management group, thank you, I can now create subscriptions wherever I want. So, keep in mind that this is an extremely sensitive area, and code injection is real and quite dangerous. So, we have changed our code, our pipeline, and we injected some stuff into our artifacts and made it run. Now, let's move on. Privilege escalation is the next one, next step in our hacking matrix. Now, I moved this to credential access because one of the things I keep stumbling upon whenever I visit new customers is that I don't have to do this. Privilege escalation is often quite useless. So we're going to go in here to start. Every Azure DevOps organization has an organization owner. This is me. Yes, that's my email. Please don't spam me. How many of you are organization owner? A couple of hands. This is the key to the kingdom. If you are organization owner, you own the organization per se. Basically, this is the same as being a member of this group, project collection administrators. This is also like the God mode. Many of you are members of this one. A couple, I guess. How many of you are running your daily work as domain admin? Or global admin? Hopefully none. One hand up, good. Don't. So if you're running with high privileges normally, I mean, we can go down a level and say how many of you are running in your project or in your specific project as administrator. The thing is, you're probably never going to use this. If you're in these pages daily, then either you are me messing about in Azure DevOps or you're doing something wrong. You rarely do need to go in and change stuff here. So what we can do, well, I'm going to imagine most of you have connected this stuff to your Entra, well, the organization, your tenant, to use your Entra accounts. And that's really good because Entra has a lot of cool features. One of them is this. Again, we're being fooled by stuff. Come on, demo gods, don't fail me now. So we have a role in our Entra that is Azure DevOps Administrator, and it's easy to think that, hey, I don't have this role, right? Cool, I'm not an administrator. Yeah, that's wrong. So this role, it actually only grants access to everything below the download button here. If you don't have this role, you can't see this stuff. But we have another feature that I can't demo, but is kind of cool. Privileged Identity Management in Azure. PIM basically means I'm a member of something, but I don't have that membership unless I actually implicitly go into Privileged Identity Management and say, hey, make me use this. And one of the things this can do is groups. Now again, I can't demo it because my P2 license went gone, which means I don't have this right now. But hopefully you do. And if you don't, buy a couple of P2 licenses. They cost like between 0 and nothing. And add groups to them. And then, instead of having me as a member of this one, we can do something like this. Have an Azure DevOps group or Azure DevOps group in Entra ID. Add this one to your administrator and then PIM your access when you need to do a change. It's a solution that's already there. We don't have to run with privileged access because again, if I want to raise my privilege as per this one, well, why should I? Why should I bother privilege escalation if you're already an admin? I already own everything you have. So do use and do limit what access you have. And remember, again, this is in the middle of your entire environment. Don't forget to go in here into your Azure DevOps or GitHub or whatever organization you have and make sure every now and then that this actually works. Is there any new settings? The very concept of importing managed identities is quite new. So we're going to look at that in a short while. Okay, so back to my matrix. Why privilege escalate your user credentials if you are already an administrator, right? Next up, we're actually going to look at another one from credential access. And that is service credentials. Because again, things happen. You know how often they do new releases of Azure DevOps? Cool, neither do I. Every now and then, they do new releases of Azure DevOps. And yes, I know people still talk about, oh, Azure DevOps is dead, everyone should use GitHub instead, Microsoft doesn't have it. Yeah, no, that's not true. They do at least once a month, they release a new version of the online version. Most often, the changes are like, bug fixes smaller. Every now and then, really, really good stuff shows up. One of them, let's see, where are we? We're going to go to the right one. Is, there we go. Updated service connections. Service connections is the way in Azure DevOps to connect to an external service. If you did this some time ago, then what you did was set up a service connection using an identity with a password. Sure, Microsoft managed password in the back end, but still a password. I can use that password to do stuff, whatever you grant access to. They improved it. So nowadays, we have workload identity federation, which is 1 billion times better. It's still an identity. If I have access to your pipelines and you have granted this identity, well, we're back to square one. I still can do stuff in your pipelines, right? Now, in many cases, we can actually remove the use of this entirely. So for example, if you're using self-hosted agents, then don't use self-hosted agents. Use managed DevOps pools. We'll be looking at those in a short while. And again, let's see, where are we? Removing these service credentials from Azure DevOps prevents me from grabbing them where in your pipeline. So, like I said, we have something called managed DevOps pools. This is quite a recent release in Azure. And when we create our hosted runners, we can, instead of use service connections to connect, instead of using your Azure DevOps hosted runners, and then use a service connection to connect to your Azure and do your magic, this one is basically the same injected into your network. So it doesn't cost anything to run a managed DevOps pool, as long as you don't run it. It costs the same as your average runner when you run it, but it comes with this. Managed identities. The best invention Azure ever did. Managed identities basically is an identity, but it's connected to a runner or a host of some kind. Now, the reason this is better is because it's closer to the use case. So if I want to check out a secret from a key vault, instead of having Azure DevOps hosting my secrets and then mounting it to a pipeline and then running that pipeline into my environment and then grabbing my secrets, I'm already on the last step when I have my managed identity. So I can just do, hey, log into this one and get it. Shifting left, something security people love to say, scarily often means shifting right. So we actually move stuff closer to the source. Another sort of sidetrack, but cool one. We have stuff like this in Azure DevOps. Variable groups. We can share variables between pipelines. And they do support secret string. They even do support key vault integration. Have you ever read the documentation of this? It mounts whatever is in here as a variable in your runner. And then it's like we try to camouflage it with stars. We don't take any responsibility for it if it leaks or if we don't, or if it's written in logs. If I use a managed identity, well, it's going to take a lot of work to actually write the managed identity into any log anywhere, because it just doesn't do this. This one will be logged if you use it. It will be seen somewhere. And you have to decrypt the password, the secret somewhere, right? It's a good encryption, RSA 2048, but it is a best effort. It literally says in the documentation, encryption of secrets is a best effort, and we may fail, and we don't take responsibility. In the managed identity key vault thing, it says, if we leak a secret, we are responsible, and we will actually help you solve the issue. Cool. So service credentials. If you are running service connections and they are old with passwords, it literally is one click. You go into the service connection and it will show up a small blob saying, hey, convert this into a workflow identity credential instead. And you click it, and it takes a couple of seconds, and then you're done. You have secured your environment. But if you never go into the GUI and actually look at it, then you won't see it. Because, well, how would you? Okay. Lateral movement. So I have taken over part of your environment. I can still deploy. I can do all kinds of cool stuff. But I want to move sideways. And we're going to look at one of the... See, where are we? There we are. One of the small but easy to forget secrets in everywhere in Azure DevOps, really. In Azure DevOps, whenever you create new stuff, I'm just doing a service connection because it's easy, you have this little flag. Grant access to all pipelines. Oop. Grant access permission to all pipelines. This one shows up here and there. It's called protected resources, and there's a lot of them in Azure DevOps. And you have no idea how often I come to a new customer and they go like, we're going to click a new one, or we're going to run our infrastructure as code, and we're going to check this one. And I'm like, hold your horses. Because what you're doing is granting every pipeline access to this resource. Let's go back and like one more step. I can run code in your pipeline if I have read access. I can change your YAML. Now you don't deploy Azure stuff in your tests, right? You deploy that in that pipeline, which I also have access to. Thank you. So the very, very short of it, when it comes to spreading from pipeline to pipeline in Azure DevOps, just don't check the box. It's that easy. And the workload you add to yourself is that the first time you do something that connects to this resource, yes, you have to go in and click, yes, I approve this access. The first time I try to inject code in your tests, you can just go, no. So don't check the box. One last thing, because we're running out of time. Defense evasion. This is also one of those new features. We're going to go back to the start. So in settings, nope. Maybe if we go to the correct one. There we go. In the settings, in the policies of Azure DevOps, you have log audit events. Up until not long ago, this was off by default. Which means you're not logging anything, nothing. You don't have no logs. It's quite easy to evade the logs if you don't log anything. It's also an API call, which if you have granted access the wrong way or have set up stuff, I can simply use the API with my logged in identity and switch it off. But this one was off. So like simple thing, go in and make sure it's on. And suddenly we have audit logs like this. These logs suck. They are crap. They tell us like 50% of the truth. But that's 50% more than 0%. Or is it? I don't know how to calculate percentage. Another feature, forwarding. Again, if I manage to grant myself access to just purge the logs or remove whatever, then yeah. And promise you, your security department will smile and look really happy if you come to them voluntarily without being asked and say, hey, I've got a bunch of security logs. I want to forward them to you. They will not complain. They will be happy. Shush, I'm done. Okay, service log manipulation, enable them. Because now, well, I'm in. I'm not going to go through the last steps because impacts and exfiltration, if I can access whatever you have, then I can do whatever I want. I can steal whatever I want and I can change whatever I want, right? Now here's the kicker. Yes, Azure DevOps Security is the one. I'm demoing Azure DevOps. But it doesn't matter which runners or which CI/CD solution you're running. You have to make sure that your CI/CD solution is updated. You have to verify it. Do not forget the little red cross in between dev and ops, because that's where bad people like me come in and do fun stuff. And hopefully, if you actually add this to your yearly security reviews, you do go in every now and then, hey, something new happened. Oh, look, there's a checkbox. I wonder what it does. Oh, look, it turned off a security issue. If you do this, whatever CI/CD solution you use, then hopefully, well, our hacker can be a sad hacker. I'm not saying you're going to protect yourself every single way. I'm just saying make it a bit harder for me to do stuff. So, time out. Do you have any questions? Just catch me outside or here or raise your hand now. If not, well, this is where you can find me on the internet or the outernet. And I hope you all go home and click every single button except grant access to all pipelines. Thank you.